So we have to talk a little bit about just how the Arduino behaves like a voltmeter. And it does so in this process that's called analog to digital conversion. Let's just talk about that a little bit. So it turns out that the Arduino is a little computer. And as you may know, computers only talk in binary. Those are the only things they understand, where things can either be a 1 or a 0. That's all computers understand. So how is it that the Arduino will sort of understand a number like a voltage that the voltmeter would read that can be a number between like 0 and 5 or 0 and 9 that comes from an analog voltage divider? How can an Arduino process such a thing? Well, what it does internally is it does something. It runs all inputs on these analog inputs right here, these 6 analog inputs you have. It runs them something through called analog to digital conversion. Now the analog always refers to, again, you can always think of this number here as some volts that exist in the real world, from your voltage divider or from a battery or from just about anything, but it's just some voltage that can be just about any number. But of course we know we have to get it to digital right here, because this is sort of what the computer inside the Arduino can understand. So what does it do? Well, not to make things too complicated, but if you recall the binary number system, what it means a bit, let's just look at a few bits here. We know that if we just look at sort of a 2-bit system here, we know that if both bits are 0, that represents actually the number 0. And we know if we have a 0, 1 like that, that represents the number 1. If we want to go to 2, it would look like this. And if you want to go to 3, it would look like this. And it keeps going on like this. Certainly computers have 8, 16, 32, even 64 bits of counting here, but you just have to remember the binary counting just a bit, how it works here. This is the number system that computers can understand because everything has to be represented as a 1 or a 0. Okay. Now, so the way the analog to digital conversion would work then is it's the Arduino's responsibility to take a voltage that it reads on A0 through A5, and remember that voltage must be between 0 and 5. That's our responsibility to make sure the number is between 0 and 5. And it somehow has to convert it to a binary number so it can be used internally in the software that we write as a computer. And it does that through the analog to digital conversion. Now it turns out that if you read the specs on the Arduino, it turns out that the Arduino has a 10-bit A to D on it. And I was going to write the word converter here, but that's kind of long. A 10-bit A to D converter. That means that the Arduino takes analog values between 0 and 5 on its analog input lines and can convert them into a number that's 10 bits long. 10 bits long. So you have something that looks like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Something like that. Now, just as a way, by way of example, suppose that the voltage on the Arduino A0 was 0. The converter would likely convert the 0 into a whole string of zeros like this. It can be really small. Suppose the voltage started to rise just a little bit, maybe to 0.01 volts or something like that. This 0 here would become a 1. Suppose the voltage started to rise some more. Maybe the binary value would rise to 2. And after that, maybe it would rise to 3. And maybe after that, it would rise to 4, something like that. As the voltage on A0 began to rise, the converter would make a binary number which was correspondingly large. So it turns out in a case like this, in 10 bits like this, the maximum number you can store is 1024. That's 2 to the 10th power. Those are sort of the exponents that we're working with here, 2 to the 10th power. So that's the most you'll get out of it. So what the Arduino does then in this process called analog to digital conversion here is you can expect, with a 10-bit analog to digital converter, you can expect 0 volts on input to be mapped into 0 binary, and you can expect 5 volts to be mapped into the number 1024. I guess we can scratch out the binary because we know they're just equivalent representations. 0 volts will be mapped into 0, the number 0 internally on the Arduino. 5 volts will be mapped into the number 1024 internally on the Arduino. And everything else will fall in between. 2.5 volts will be mapped into 512, and any sort of linear ratio you can think of in there. So any number between 0 and 5 will have a unique representation between 0 and 1024 inside the Arduino that are then available for use. So when we looked at this code in the last video right here, remember we said that this analog read line right here is where the Arduino behaves like a voltmeter. So indeed, when you do an analog read on an analog input line, in this case A0 here, which is this first line on the Arduino right here, the first analog line going in, A here is going to be a number between 0 and 1024. That's what you get. Now you might be a little confused. I was like, oh, wait a minute. I thought the Arduino was behaving like a voltmeter. How come it's not giving me a volt? Well, it doesn't do that directly, but it's very easy to get at voltages. But you can be rest assured that although these aren't voltages, these aren't actually the number that you would read on your voltmeter. They are numbers that are proportional to the voltage, because you know that 0 is 0 volts, 1024 is 5 volts. So any logic you might be thinking of implementing or whatnot would work just fine. For instance, suppose you wanted to do something if your voltage divider reached 2.5 volts. You could think about the 2.5 volts, or if you were going to the Arduino, you would just think about the number 512, because that's what 2.5 volts would get converted into according to our linear scale here of the way the analog to digital converter works in there. So that's in a nutshell what the Arduino is doing here. But we did want to just put up one more little code base you can try if you're so motivated to get into voltages for your work. You can do something like this. Here's the setup function, which will talk to the serial port once again here. And here's all the same things that we used in the previous code. Here's A, that raw input, and here's A here. And remember, this value A here is going to be between 0 and 1024, just like we said again. And you might be upset over having to use such large numbers you want voltages. Well, remember the way the mapping works right here. Here's how we can get voltages out of a number here. If we just take A and divide it by 1024, this will give us the fraction between 0 and 1 that A represents of the whole so-called dynamic range the analog to digital converter can support on the Arduino. For instance, if A was 1024, this fraction would be 1. If A was 0, it would be 0. If A was 512, this fraction would be a half. Then what we do is we just sort of multiply that by 5 volts, because we know 5 is the maximum voltage the Arduino is going to expect, and this will give us our precious volts. So it's very easy just to do the conversion using the Arduino, and here in fact we have it. V is 5 times A divided by 1024. Just this formula right here. And then instead of just printing out A the way we did in the previous code here, we can print out V, and we'll actually get volts on the screen, and we actually have a running Arduino simulation which you can see in the very next video.